Now, we're going to go through this process again, but instead of simplifying everywhere, every time we get a chance, so instead of changing this from 11 over 3 times 1/2 all squared and changing that to 121 over 36, we're going to leave it closer to this form. So remember, again, ax squared plus bx plus c is 0. We're starting with 3x squared plus 11x plus 8 is 0. We're doing the same process. So it's minus 8 on both sides, subtract 8, cancels here. So we have 3x squared plus 11x equals negative 8. This step's also the same. We want to get the x squared by itself, so or without the number in front, so to get rid of that variable, divide everything by 3. So we're left with x squared plus 11/3 x equals negative 8/3. So far it's all been the same. Here's where it's going to get a little different. We're still doing the same process. We're taking this 11/3 because we want to complete the square right here so that we can factor this. So we're going to take the 11/3, multiply by 1/2, and square it. But instead of reducing that or making that 121 over 36, we would change that to 11 over 3 times 2, all squared. So we need to add that to both sides, just like we did before. So we have x squared plus 11 over 3x plus 11 over 3 times 2 squared equals, remember we add to this side, have to add to the other side as well. So 11 over 3 times 2 all squared minus 8 over 3. All right, I know this is a little bit more confusing, but this is the exact same thing we just did. So we want to complete our square here. Now remember, whenever we had the 121 over 36 here, we had to take the square root of that to get 11 over 6. Well, we've already got the 11 over 3 times 2 squared, so to take the square root to figure out how to factor, the squared goes away. It's kind of already done for us. So we have x plus 11 over 3 times 2, all squared, quantity squared, equals 11 over 3 times 2, all squared minus 8 over 3. Now, our next step was to combine this. To do that, we need a common denominator. So I'm going to take the squared and we're going to distribute that through. So we have x plus 11 over 3 times 2, all squared, equals 11 squared over 3 squared times 2 squared minus 8 over 3. Now, we need a common denominator. We have a 3 here, and over here we have a 3 squared and a 2 squared. So we have 3 times 3 times 2 times 2. So on this side, what we're missing is a 3 and a 2 and a 2. Or we can rewrite this part just as 2 squared. Remember, whatever we do to the bottom, we have to do to the top. So times 3 times 2 squared. Again, this is the same as 12 over 12. It's just like we did before. We're just keeping it factored. So we have x plus 11 over 3 times 2, all squared, equals 11 squared over 3 squared times 2 squared minus 8 times 3 times 2 squared, all over, this is 3 squared, 3 times 3, and our 2 squared. So, x plus 11 over 3 times 2, all squared, equals, we now have a common denominator, so we can put the tops together. 11 squared minus 8 times 3 times 2 squared, all over 3 squared times 2 squared. Now, we need to take the square root. Says we need to get rid of this squared here, so square rooting both sides. This cancels. Remember, this is plus or minus. So we're going to have x plus 11 over 3 times 2. So remember, we got rid of our squared right here. Equals plus or minus the square root of 11 squared minus 8 times 3 times 2 squared all over 3 squared times 2 squared. Now, just the same way that we took the square root of the top and the square root of the bottom, we're going to do that over here also. So we have x plus 11 over 3 times 2 equals plus or minus the square root of 11 squared minus 8 times 3 times 2 squared all over the square root of 3 squared times 2 squared. All right, now the square root of 3 squared and 2 squared, this is the same thing, just to do a little bit of side work. This is the same thing as the square root of 3 squared times the square root of 2 squared. These cancel out, the square root and the squared. So this equals 3 times 2. So using that little bit of side work, we know that we have x plus 11 over 3 times 2 equals plus or minus the square root of 11 squared minus 8 times 3 times 2 squared all over 3 times 2. Just about have x by itself. So all we have to do is subtract the 11 over 3 times 2 from both sides. So minus 11 over 3 times 2 minus 11 over 3 times 2. Cancels here. So x equals negative 11 over 3 times 2 plus or minus the square root of 11 squared minus 8 times 3 times 2 squared over 3 times 2. Look at this, common denominator, put it together. X equals negative 11 plus or minus the square root of 11 squared minus 8 times 3 times 2 squared all over 3 times 2. Now, I know this looks really strange. It gives us the same answers we got before. But what I want to do is go back right here. A is 3, B is 11, and C is 8. Now we look back to our quadratic equation. So anywhere we see a 3, 11, or an 8, we're going to substitute in the letters A, B, and C. So x equals negative, here's an 11, so B, so negative B plus or minus the square root, 11 again, so B squared, minus, here's an 8, there's C, times 3 is A. And in this case, 2 squared is just 2 squared because there's not a variable we can put in there for it. So we're going to have that as just 4. All over 3 is A. And 2 is just 2 because there's not a variable we can substitute in there. Now, let's make that a little prettier. Putting this together, we're going to get x equals the opposite of b plus or minus the square root of b squared. Instead of CA4, let's make that 4AC. All over, instead of a times 2, 2a. And there we go. This is the quadratic formula. You can take this, and whenever you take any of your quadratic equations and put them in the form ax squared plus bx plus c equals 0, you can take the a, b, and c from that equation and plug in here, and it'll give you your solutions. Are there any questions? All right, let's go on to an example.